All right, welcome to page 3 of the review. We are going to look at the answers to 15 through 22. First two problems. State if the triangles in each pair are similar. If so, state how you know they are similar. Complete the similarity statement. So the first thing we're going to notice is we have vertical angles that are congruent. We have these two vertical angles that are congruent. So angle RVQ is congruent to angle TVU, because they are vertical angles. The next thing we need to look at is ratios of the sides. We have these sides that sandwich the angles. So I'm thinking we will use side angle side to try this. So what I'm going to do is I'm going to look at the 24, and the corresponding side of the other triangle would be the 54 because it's the smaller of the two sandwiching sides. So what I need to check is, does the ratio of 24 to 54, does that ratio equal the ratio of, now I started in the smaller triangle, so I need to go back and work with the 40 over the 90. So the question is, are those two ratios equal? And we're going to either reduce the fractions to compare, completely reduce both fractions, or we can compare decimals. I think we'll look at both. So 24 divided by 54, I can divide out a 6, that reduces to 4 over 9. And 40 over 90 does reduce to 4 over 9, so those are equal. If you do the decimals instead, you do 24 divided by 54, and that's a repeating 4. Okay. And then that's a repeating 4. 40 divided by 90 is also a repeating 4. So whether you divide and use decimals or whether you reduce and compare fractions, they have to be exactly the same. But those are exactly the same. So our triangles are similar by side angle side. And then we complete the similarity statement by saying triangle VUT is similar to triangle, so V corresponds to itself. We went from V to U, so we went across the 54, so we need to go across the 24, which is V to Q, and then we need to go to R to finish it off. Triangle VQR. Remember, the order matters. Okay, triangle VQR. All right, next one, number 16. Are the triangles similar? So what I have is a small triangle at the top, and then I have a larger triangle right here. So what we're going to do is we're going to notice that angle at the top is congruent to itself. So angle F is congruent to itself. I'm going to have to use just angles here because I don't know anything about the side lengths. So angle F is congruent to itself. The two triangles share that angle. We have some parallel lines here, and those parallel lines are cut by this transversal. So these corresponding angles right there and right there, that pair of corresponding angles are congruent. So angle FSR is congruent to angle FHG. Because I have a pair of angles here that are congruent and a pair of angles, second pair of angles that are congruent, the triangles are similar by the angle-angle similarity theorem. Last thing we have to do is we need to write the similarity statement, complete it. So triangle FGH is similar to triangle, we're going to start at the F. Remember, these two were congruent. That means angle G must be congruent to the angle there at point R. So we're going to go FRS. And we have our similarity statement. All right, let's move on to 17 and 18, where we again have some parallel lines. Where those little arrows mean we have parallel lines. So we've got 3 parallel lines here, and we're looking for the missing length right here. I'm going to label that x. So again, we're going to do a proportion, a ratio equal to a ratio. And there's a couple different ways that you can do it, but I'm going to just take the pieces here created by those parallel lines. So the x over the 12, that has to equal, so I need to keep the 15 on top of the 9. Location, location. So what we're going to do is solve that equation. We could cross multiply, or we could just multiply both sides by 12. Because to get the x by itself, I just need to move the 12. How do we undo divide? We multiply. So we'll multiply by 12. That turns into a 1. 1 times x is just x. And then 15 over 9 times 12. You can do that a couple different ways. 15 times 12 is 180, and then divide by 9. Or I could do 15 divided by 9, turn that into a decimal, and then multiply by 12. Either way I do it, I get x equals 20. Number 18. First of all, notice the side that you're trying to find is this length right here. So there's x. Notice these are pieces. So the x and then the 25 is this piece right here. So I need to split the other side into pieces. I have the 12. I know the whole length. So 27 take away 12 is 15. So I have a 15 right there. And then I will set up the proportion again. So I'll do the x divided by the 25. Pieces over here on this side has to equal the same ratio. Make sure you put the 12 on the top. 12 over the 15. All right, now we will solve the equation. Similar to what we did in the last one, we can multiply both sides by 25. So 25 times x over 25, that's over 1. The 25s turn into a 1 here. And whatever I do on the left side, I have to do the same on the right. So 12 times 25 divided by 15, or I can do 12 divided by 15 and get 0.8, and then multiply that decimal by 25. You get a 20 again. All right, x equals 20. Okay, number 19, 20, 21, and 22 are about parallelograms. So we have parallelograms. So we're going to look at these pieces. So from D to F, that length is 12. From X to F is X plus 2. I'm going to take that 12 and split it into 2 equal pieces. I've got a 6 and I've got a 6. But I also have XF being X plus 2. So what I have is the equation X plus 2 equals 6. Subtract 2 from both sides, we get that X has to equal 4. Next question. We're going to take a look at this parallelogram has a diagonal drawn. That diagonal right there cuts through these parallel lines and creates an angle here that's equal to an alternate interior angle right there. Those alternate interior angles are congruent. So what I can do is I can label this angle as 4x minus 10. Now this is not the only way to do the problem. There are other ways. This is just one way. So I'm going to set up the equation where the 3 angles of my triangle, now I'm talking about this triangle right here, those 3 angles have to add up to 180 degrees. So 66 plus 80 plus 4x minus 10 have to equal 180 when I add them up. All right, so let's combine the like terms. 66 plus 80 take away 10 is 136. Subtract 136 from both sides. We get 4x equals 44. Divide both sides by 4. We get the x has to equal 11, and we are finished. Okay, the last two are super simple. If we remember that opposite sides of a parallelogram have to be congruent. So those two sides are equal length. Congruent means equal length when we're talking about line segments. So x plus 5 has to equal 13. We'll subtract a 5 from both sides. and come up with x equals 8. Okay, last one. Opposite sides of a parallelogram are congruent, which means the same length. So x plus 2 has to equal 2x minus 4. I need to get the x's on the same side and the terms that don't involve x, the constants, on the opposite side. So I'm going to subtract a 2x. And I'm going to have negative x plus 2 equals negative 4. I'm going to subtract a 2 from both sides. Negative x equals negative 6. Then I'm going to divide both sides by negative 1. X equals 6. And we are done.